Hi, so welcome to my tutorial on Python scripting in Pymol. So in the last video, I talked about how to make a nice automate a figure like this with Pymol or with a Python script, how to use that on other molecules as well. And I also showed you how to basically run the script in Pymol. Now I'm going to show you how you would build this script. So again, as I said in my last video, you do your imports. So from Pymol import command, this allows you access to the Pymol API and util, which is another Pymol command useful for coloring atoms by their individual colors. And then import OS and sys for file handling. Then you set the global settings. So image directory, we have set as none. And what you'll see later is that when it's set as none, the images will be saved in your home directory in a folder called temp. If you want to change this to a particular directory, you can just enter it here and it'll be saved as a default for global variable image directory. Then you can set the width and height of the figures, the DPI, and the anti-alias. You can also, this is a current view. It basically gets the current view from the GUI. So this is very useful. You can do it in Python, which you can't do with a .pml file. And there you have to actually explicitly set the matrix. Then you can set the ligand color. So here it's lime green. And then do some other things like the transparent object color, the object transparency. And the selection name, I have a default as always being cell, so that when you're in Pymol, you don't have to change the name. So the cell is a selection you want to have as a transparent, right? It's like these beta sheets. So the first thing we do is do the Pymol settings. So in the .pml file, all you had to do was say set ray shadow 0, but here we need to call the Python API. So cmd, the command cmd.set ray shadows 0. So these are pretty straightforward, very similar to the .pml, except you have to wrap them in a cmd function. And there's some other functions here, but first I want to show you the main function that's being run. So I talked about this in the last tutorial. You need a function to run everything. Usually this is called main, and it's run when you run the script. But you can't really do that when you're running in Pymol. So here, you can call this whatever you want. I called it run selection. If you're running a full script in Pymol, it just takes, everything is interpreted as a string. So the first argument has to be a string. And then we can call Pymol settings. And after that, we're going to parse the string. So all of this is just parsing the string into different arguments. So the protein is always the first argument, and then the second and thirds of the active site. And then we have a ligand color off argument that if it's there, it's always the fourth argument. So if you have the length of arguments equals 4, then, and you see this, then it will set the ligand color off so that the GUI will only, the ligand will be colored by the GUI and not by the global variable, which was pale green in this case. And then you call your functions. So the select objects function, which we're going to talk about go through each one of these, but this one is just to ensure that the objects that the user has set are actually our objects in Pymol. And then the residue list is returned from the get selection residues. So we make a selection of residues we want to have transparent. And then this gets returned as a residue list. And then the image directory gets returned from the set image directory list, or set image directory function. And this takes the global variable image directory, which you can set up there or is set to none. And then in this function, if you set it to none, it'll be automatically find your home directory in a file called temp. And then here we create the figures. So the protein figure is called function is called, it uses protein, which we have here, the residue list, which is here, the image directory, which is here, and the current view, which is a global variable. It also returns. So I usually only like to do one thing per function, but sometimes for brevity, I'll just have it maybe do one or two things. It returns the transparent object, and then this is passed into a function later called transparent figure, so protein transparent object. The active site figure doesn't return anything. It just uses the arguments protein, active sites, image directory, and current view. And then the transparent figure doesn't return anything either. They just both make the active site and transparent images. So you run all that, you get the 4 images. The other thing you should know is that in order to debug these, like in Pymol, and work through them one by one, you need to have access to them. So you do the cmd.extend command, and it's pretty straightforward. Cmd.extend, you just have the name that you want to call the command, and then the actual command, select objects. So we have select objects up here, and then select objects down here. So we do this for each function. And then when you run the script, it prints out some usage cases so that you'll know how to use it. And then here I just have, for each of these I have function tests. So I test the function with these inputs. And so that's what we're going to go through right now. So I'll go over to Pymol. So here we are in Pymol. The first thing you want to do, and this is, you can download this file from the notes, from the show notes, but what I've called it as, it's lesson 3 gfp.psc. So these are the residues selected that we want to hide. Now, if I was going to run the whole thing, like I talked about in the past video, I would just do run selection. But we're going to test each function. So first we just have to do file, run script, and then scripts, navigate to the script, Python scripting lesson 3. And again, if you look, so we'll get something, yeah. If you look down here, you'll see that it has like usage. So run selection, protein, ligand, and then active site residues. So the first thing we want to do is test out each function. So we're going to start with select objects, and I'll just copy and paste this to make this a little faster. And we'll type that in the command line, select objects. Right, so what does it return? So this function, select objects, will print out the objects that are found in the command line. If they're not found, it'll print an error and exit that they're not found. So 1EMA organics is up here, and the rest of these can be found up in the object list here. So the next thing to do is to actually run the get selection function. Now if we go up to the get selection function, basically it's just lists the selections. It gets the selection and the selection name. The selection name is set in the global variable here as cell. So that's a default name for any selection in Pymol. So that way we don't have to change it. So we'll run this. Get selection residues, 1EMA cell, and then it returns a list. These are all the residues that you see are highlighted here. There's other functions will take this in as an input. But for now, we're just testing it. So the next function to test is the set image directory. So we'll test this without an argument first. And if you do that, it just defaults to the user's home directory and a file called temp, tmp. We can also set the directory by putting in a path, and the script will check the path and make sure it exists. If it does, it'll print it out and say, okay, we found it. It's in this directory. So if we look up at set image directory, basically its default is set as none, and if it's set as none, it'll go to making a temp directory in the user's home directory, unless it already exists, and then it'll return that. Otherwise, if there is another image directory in there, it'll just return that. So it's pretty straightforward, but it works pretty well. So the next thing we're going to test, the next function, is the first protein figure. So this makes the first protein figure. So we'll test protein figure, and it takes in C. So you can see here, it takes in the object, protein object, then that list. Usually in a script, this list would be coming from another function, but since we're just testing it, we put in the list, and then we put in the path to where we want the images stored, and then we run cmd.getView because it takes in a view, and we can just do this with cmd.getView. It gets the current view. We run that, and then we have our first image. So we can look and see what's going on. We won't go into too much detail. I have a blog that would be useful if you want more detail. But basically, it takes in the residue list, and then it pads it with 2 residues on either side. And that's to make it look smooth, so there's no chain breaks when we put the images together. And then you just do some basic hiding, showing the cartoon, saving the image. Okay, so now we're going to make the other 2 images. So let's look at active site figure. And it runs this in a similar way, except it doesn't return anything, it just makes a figure. So the protein figure actually does make a figure and also returns a transparent figure. It would be nicer to have a separate function, so one function does one thing, but just for brevity, I decided to put it in there. So we'll now look at the active site figure. We'll test that out. All right, so it's the active site figure 1 EMA, and then it takes in a list. And this is a list of the active sites, so the residues and the organics, and the path to save the images, and then cmd.getView, which gets the current view of the GUI. So you run that, and then you have the image saved of your ligand and residues. So finally, you run the same thing on transparent figures. And the only difference is that a transparent figure needs a transparent object. And usually you would get that from running the protein figure function. So the protein figure function will also return the protein transparent figure object. But here we're just testing it, so we want to provide one. So that's why I made one here. And you can download this Pymol show file in the notes. And again, you have the 2 beta strands. So this is really all you need to do. You also might want to run the Pymol settings function, test that as well. We won't do that here, but you can test that on your own. And then you can also test functions you can test this on other proteins. So it's extendable to other proteins, which makes it very useful. So if you like this, please subscribe if you want to see more. If you have any suggestions, please let me know in the comments. Okay, thank you.